In this video, we look at piecewise graphs. So what are piecewise graphs? Now, they are graphs that involve a number of different graphs on the one plot together. So you can see this first graph here. There's one little section here that's clearly one linear function. And then we have another segment here, which is a different function, another one here, and another one here. So this graph here involves four separate functions over a limited value of x. So we call those values of x the domain. So this one here runs between -3 and -1. Okay, so that is where we're talking about the domain, the values of x in which the graph runs. Okay, this section here would be between -1 and 0 for x. This one here would be between 0 and 2. And this one between 2 and something. We can't really see the end of it. It might go on forever, or it might stop before there. This one here has three different sections. One runs from the domain 0 to 5. This little section here between 5 and 8. And this section here between 8 and 12. Okay, so let's have a little bit closer look at these graphs. Move me here. So example 1, the graph pictured below involves three different lines. This is the one from earlier where we had this section, a second section, and a third section. Looking at this here, the first section here starts at y is 0, so my y-intercept is 0, and it's going up by 1 and across by 1, so it has a gradient of 1. Okay, so that first section there has the equation y equals x. It runs between 0 and 5 on our x-axis, which we can say has a domain mathematically of this, 0 less than or equal to x less than or equal to 5. Okay, so together we would write that model here, incorporating both of these sections into it. So the actual equation for the line as well as the domain would be written here as y equals x, comma, and then we would write the domain, i.e. that is the values for x in which the graph runs. The second section here, we can see here, would have an equation of y equals 5, okay? It's just a nice flat horizontal line, and if it continued, it would run through 5 on the axis here. So we can see here, it's got the equation y equals 5, okay? It does have a limited domain. It's running between x is 5 and x is 8, okay? So we'll say that as this here. So we can write that section, bringing those two things together, the equation for the line as well as the domain. We can write that as y equals 5, comma, and this section here, okay, which is telling me that x is bound by 5 and 8. The final section here, and that's a little bit harder to tell what the graph is. I'll just tell you what that one is. It has an equation y equals 0.5x plus 1. We can see obviously it's limited between x is 8 and x is 12. All right, so we'd say that as 8 less than or equal to x less than or equal to 12. Bringing those two together will give us our model for that last section of y equals 0.5x plus 1, comma, and x is bound between 8 and 12. Okay, so together we would write this function here as this. Okay, so if you are asked to sketch a piecewise graph that looks like this, we would generally be using the calculator to do that. So we'll start another question where you guys will be forming one graph out of a number of different pieces. So let's have a look at this one. We've gotten the following model. So we can see on this one here, we have three different sections that we are going to have to draw. The first section runs between 0 and 3 on our x-axis. The next section runs between 3 and 8. And the final section will run between 8 and 10. So I would grab the calculator out for this one. Let's get it out here. And what I'd be doing is going to my graphs and tables. In our first part here, we're going to put the first graph. So that's a y equals 2x graph. The next one is a y equals 6 graph. And the next one is a y equals -3x plus 30. Now, if I graph these all together now, you would get a funny sort of a view of this. If we zoom out a little bit, we can hopefully see a little bit more of it. Now, what we've done here is just graph these sections. We haven't limited the domains. We can do that on the calculator though, which would make this actually represent this entire piecewise function. So we do that by going and limiting each of these individually as per the domains given in the question. So for my first one, we want to limit that blue line to run between 0 and 3 only on our x-axis. So I'll go up here. After I've written the equation, I would go keyboard, and we're going to find on math 3, we're going to find this little icon here. That little line means given that. So I'm going to write graph y equals 2x, given that, and I'm going to write this little section straight after it. So I'll go 0, so equal to x, so equal to 3. Okay, I'll go down and do the same for the others. Y equals 6, given that, 3, and the last one, given that 8, okay. So have one last minute look and just check that this matches what you've got over here. Yeah, it looks pretty good to me, and we'll hit the graph button again. Okay, and that gives us our piecewise graph. So I'm going to zoom into that one just so I can see it a bit better. I'm going to use that one there, my zoom box, and I will zoom in here. All right, and you can clearly see this first section, the second section, and the third section. So once you've done that, you would go and transfer that onto your graph. All right, let's try another one. I'll move me over here. So example 3, given the following model, y equals x plus 2, y equals negative 2x plus 11, and we have some domains here. Now, on these ones here, obviously there's only 2 sections, so we're going to have 2 separate little lines on this graph here. This A, this is telling us that it doesn't know where it's going to cross. Okay, so these lines are going to meet at some point A, but we have to first find what that point is. How we do that is we first need to solve the value of A using simultaneous equations. This is one again where I would grab the calculator. So solving simultaneous equations is done using this one here. So go into your keyboard, go math 1, and find that little icon there. Once you've hit that, that will come up. And you'll start to type in this equation, and then the second equation into the other one, and then into that last box, you'll go x comma y. So it's going to look just like that. You can pause there if you like while you're having a go. Otherwise, I'll keep going. The solution here you can see is x is 3, y is 5. So that tells me that these two graphs here are going to link up at the coordinate 3, 5. Now these A values, or the values that are given in this section here in the domain, are always going to be the x values. So in this case, your A here is going to be whatever your x is, which is going to be 3. All right. If we're sketching that graph, again, I would get my calculator out. We'll get it out again. All right. I'm going to clear everything that's in here. Edit clear all, and I'll clear the top section as well. Edit clear all. All right, so my first graph was x plus 2, and I'm going to go and put the domain in here. Given that, 1, and then instead of that A, I'm going to put in that found value that I found by solving simultaneously. And then here, I'll do that again as well. 3 in here. All right, again, one last quick look at it just to make sure you've entered that all correctly. Looks pretty good to me. And we'll tick those boxes and hit graph. All right, it's a bit hard to see. If they're a bit hard to see, you can use any of these zoom tools here. Your domains here will also give you a hint about what values they will fall between. Okay, sometimes they are a bit hard though to see, so just keep zooming out until you see it, and then you can use something like that zoom box that I'm using now, and we can highlight the section we're interested in. Okay, So the graph here, the first section will run from this point here to here, and the next one takes over up until x is 5. Okay, so nice and easy. I want you to do everything on the calculator for these ones. So now go and have a go at those concepts on worksheet 1.